We're going to do rotations two different ways today. The first type of rotation we're going to do by hand using a protractor and a ruler. And the second type of rotation, our center of rotation, basically the fixed point where our object or point rotates off of, is going to be at the origin on our coordinate plane. And we actually have some rules for that we can follow that make it nice and easy to rotate. So first thing, for our rotation, we have a fixed point that it rotates. And in this case, in my example, my fixed point is C. It's going to rotate about C. Almost like the sun, right? The planets orbit around the sun. Well, our points and our images are going to orbit or rotate around a center of rotation. And in this case, I'm rotating 120 degrees. So here was my initial point, A, and we rotated 120 degrees. And if you notice, we moved counterclockwise, and we're going to talk about a rule for that. We moved counterclockwise 120 degrees. And if you look, we're the exact same distance away from the center still. So A was this distance, and A prime is the exact same distance, just 120 degrees from the original spot. And so that's how it works. The angle of rotation is found by moving the amount of the angle and keeping the exact same distance from the center. So let's go ahead and do an example here. Well, here's our rule. All rotations will be counterclockwise unless stated otherwise, to be consistent, because that's kind of how we did with our vectors anyway. So just to be consistent, everything is counterclockwise unless stated otherwise. So copy quadrilateral RSTV and point A, then use a protractor and ruler to draw a 45-degree rotation of RSTV about point A. So I have my figure drawn here. Once it appears, slow motion. Okay, so RSTV, and I want to rotate it 45 degrees about point A. Okay, well, I already measured how far away point R is from the center A. And what we want to do in my blue words down there, each point and its image should be the same distance from A and make a 45-degree angle with each other. So just deal with one point at a time. So for example, I'm just going to deal with point R right now. So I measured it. It was 2.7 centimeters away. So first thing I got to do is measure my 45-degree angle. So I'm going to bring my protractor. I put my center right on A, which is my center rotation. Get my 0 degrees lined up on there. And then I'm going to mark where 45 degrees is about at. Looks like about right here, 45 degrees. Okay, I got to look at my inside markings here because they start at 0. Bring the protractor away. Now get your ruler in here. Make sure you're looking at centimeters because that's what I measured in. I'm going to line it up with my marking. Put the 0 right at A, and 2.7 is about right there. So there should be A prime. So I don't even need to draw my line in. I can just put my dot, and there would be, oh, R prime, my fault, R prime. And if I took a look at that, I just kind of drew in a little dash line here, that would be exactly 45 degrees and the exact same distance. This would also be 2.7 centimeters. So you just deal with one point at a time. And so if I were to go do the next point, I'm just going to do one more. Let's just say, let's pick S next. So what I would do is, I would take the protractor, go back to my center, which is at A, and I want to line it up with S. Well, I'm going to need a little bit bigger protractor here. Okay, that was nice. So I line it up on S. So there's 0 going through S. Let me get even a little bigger. Okay, so we're lined up at S, and 45 degrees would be right there. Okay, so let's move our protractor out of here. Whoop, all kinds of stuff. Take my ruler. Well, I got to measure how far S is away from the center. So S is about 6.6, it looks like. About 6.6 centimeters. So I got to measure 6.6 centimeters from that center to my 45-degree rotation that I found. So 6.6 is about right here. Move my ruler away, fill it in a little more, and I say S prime. And now I can connect those two. I'm going to use your ruler to connect. So there we go. So now S was rotated 45 degrees. And I would do that with T and with V, and eventually my shape would look just like my original. So you have T prime and V prime. So just make sure to go through that process with the protractor and the ruler for all 4 points. Okay, and you got one problem on your assignment that you're going to do that. So you have to use a protractor and a ruler for each point. Okay, it's nice if we're using a coordinate plane and the center is at the origin. So these only work when the center is at the origin. Okay, and we have 3 rules. We're going to rotate 90 degrees, 180 degrees, and 270 degrees. And easy little rules with these. So if we just call my original point XY, if I have a 90-degree rotation and the center is at the origin, all I have to do is just switch the spots of the X and the Y and negate the Y. So they just flip-flop and I negate the first term. So in this case, P was 5,2. So to find the 90-degree rotation, P prime would be, we'll flip their spots and negate the first term. So -2, 5, which we have right there. Made a 90-degree rotation and the center was at the origin. Okay, with a 180-degree rotation, all that happens is we just negate both the X and the Y. So if I take a look, here was P, my original, 5,2. So P prime would be -5, -2. And if it looks, it has the 180-degree rotation counterclockwise. Nice and perfect there. And my last rule, it's kind of like the 90 degrees. You flip-flop them, but this time you negate, well, the second one. So you flip-flop the X and the Y, and you negate the second spot, or the X this time. So if I'm looking, P was at 5,2. So to get to P prime off a 270-degree rotation, we flip-flop and negate the second one. So 2, -5, which you can see right here. So it makes 270, or 3/4 of a circle around. Okay, so those things we have to memorize. And they kind of have a little bit of pattern to them, right? It starts off with the 90-degree, it flip-flops, negates the first one. They flip-flop back, and they're both negated. And then they flip-flop again, and we negate the second one. Okay, it's kind of a little pattern to it. Let's try to come up with a way to help you memorize that. So in this case, I'm going to graph the figure and its image after the specified rotation about the origin. So this is nice. When it says about the origin, I got my rules if it's 90 degrees, 180 degrees, or 270. And if I take a look here, it says parallelogram MPQV has the following vertices, and we're going to rotate 270. So I got a rule for that. Well, let's take a look. So here's my points. What I would do, I'd go ahead, even if I don't graph my original right away, I might just find what my new points are going to be in my new image. Well, if you think about it, so here's my original points, the X, Y. I got them written down there for MPQV. Well, on a 270-degree rotation, what we just learned? We flip-flop them, so the Y comes first, the X comes second, and which one do we negate? The second one, right? If I would look back, that's how it works. It flip-flops, and we negate the X. We negate the second one out. So I might just do that for all these. So M prime would be, we'll flip-flop, so 3, and then -6 becomes a +6. We just negate it, do the opposite. P prime would be 3, instead of -2, +2. Q prime would be, well, -2 comes first now, and this changes sign, so +3, there we go. And V prime, flip-flop them, so -2, and then -7 becomes +7. So now I already got all my points. So let's go ahead and let's look at my original graph. And I already graphed M prime on a 270-degree rotation. So M over here is at -6, 3. M prime is over here at 3, 6. So now I don't need a ruler and a protractor, because all I got to do is just graph my points. So P is at 3, 2, or P prime, my fault. Q prime is at -2, 3. So this matches up with that one. And finally, V is at -2, 7. Okay, so it's nice. We don't have to use our protractor or our ruler as long as it's rotated about the origin. Just got to remember your rules. And that's all we got.